Hello friends, welcome to another video on the Python Novice to Pro channel. Now, what does a game of a deck of cards like this one? I'll add deck, I'll shuffle and play the game. What does a game of deck of cards like this and the ability to navigate through a website? I can go backward, I can go forward on the website like this, I can go backward. What does these two have in common? Well, as you've noticed, it is the ability for the software to understand what comes previously, the data that comes previously, and what comes next, the data that comes next. If you have been following my videos on linked lists, last time I told you about single linked lists. Now, today, this is the use case for a doubly linked list. Let me use a diagram to show you what a doubly linked list is. Remember I told you about what comes first and what comes previously. Let me show you the diagram for a doubly linked list. This is it. Good. So this is the diagram for a doubly linked list. As you can see, similarly to a single linked list, a doubly linked list is made of nodes. This one, the front one, is the head node. This one is a node in between, and this last one is the head node. As you can see from this diagram, each node has 2 pointers. You remember, single linked lists have only one pointer, the next pointer. But a double linked list has a previous pointer that helps you to know what comes previously, like in the navigation example, and then it has a next pointer that helps you to know what comes after it, the next pointer, and then it contains the data or the payload. So this is the example of a doubly linked list. Also, the head node or the front node of a doubly linked list has a previous pointer pointing to null, and the last node or the head nodes of a doubly linked list have the next pointer pointing to null. So you can see vividly the difference between a single linked list and a doubly linked list. I've written a code there that shows how you can create a basic doubly linked list. I'll explain the code, then we'll run it to show how it works. First, you have to create the node class and then the doubly linked list class. In the node class, which is here, the constructor contains the 3 elements of the node. First, you have the data, then you have the next pointer and the previous pointer. When you are creating the node, you pass in the data, then the next pointer will point to null and the previous pointer will point to null. You populate this next and previous when it becomes part of a doubly linked list. Then we'll come to the doubly linked list class. The constructor is just the head pointer, which points to null until you pass in a node. Now, I've created a helper method here, the ability to print the contents of a doubly linked list. Let me explain how the printdll method works. First, you start with a node that goes to the head node, self.head here. Then you create a string where you print the data for each of the nodes. It's an empty string. Then you traverse the doubly linked list, looking for when current becomes the last node. So for each loop, you get the data from the current node, convert it, cast it to a string, add this arrow sign, and then store it in the dl.data. This plus sign means you keep adding it to the previous string or data that was there. Then when you are through with the current node, you go on to the next node, which is let current node point to the current.next. You go on to the next node, which is this line 24. So as you keep on looping through, you keep on going from one node to the next using the current.next. When you are through with putting all the data as the dl_data string, then you look at this last arrow sign. You strip off this last arrow sign, and then you print the contents of your double linked list in this line 27. Now let's check it now. I'll show you how I did it. First, we created the nodes. Remember, in the single linked list, we did not create the nodes directly in this section, but we use methods. As we go on, we will see methods we can use to insert nodes into the double linked list. But first, for now, we just create the first, second, and third node. You see that the nodes has data. First node has 1 as data, second has 2, and third has 3. Then on this line 35, we'll create the double linked list. Then, as it's an empty double linked list, we'll say let the head pointer point to the first. And remember, a double linked list has a next and previous, and the head nodes of the double linked list, the previous should point to null. Remember from the diagram, from this diagram, the head node should point to null. That's it. So that's why here the previous points to null. Then after adding the first node as the head of the double linked list, we add the second. How do you do that? You say let the first.next point to the second node, and let the second.previous point to the first, just like here. This is the first, this is the second. Let the first and next pointer point to second, and let the second previous point to first. That's it. And we do the same thing for the third. Let the second.next point to the third, and third.previous point to the second. That's it. So you can see that we will have a double linked list where the first or head node is 1, the second is 2, and the third is 3. So this is it. This is it. First is 1, second is 2, and the third is 3. Now, what are the advantages of having a double linked list like this? Just as I show you in the web page navigation, you can move in both forward and backward direction at will. It makes it very easy. You can also easily delete nodes in a double linked list. As I'll show you a method in this class that you can use to delete nodes. And remember, insertion is efficient at each node. Remember, the insertion is constant time in the single linked list, so the insertion in double linked list is also constant time efficiency. But double linked lists have some disadvantages. First is that you need extra space, extra memory to store the extra pointers. You see, we're having next pointer and previous pointer for each node. That's extra load for each node. So you need extra space. And also, you need more time because of the pointer overhead. As you are going between pointers, you need more time to traverse the double linked list. And a double linked list does not allow random access to elements. Remember, a list gives you random access to elements, but double linked list does not allow it. Now, this code is just the bare minimum for our double linked list. We would like the ability to insert nodes, so that we don't do it through this section here, through this main section. We like the ability to insert nodes programmatically. I'll show you 3 ways you can insert nodes. Look at this figure here. I'll show you how we can insert nodes at the front, how we can insert nodes between the front and the ends, maybe at the middle, or so. Maybe we can insert a 3rd node here, and then how we can insert nodes at the end. Now, similar to inserting nodes at the front, at the beginning, I called it the push method. The push method helps us to insert node at the front of the double linked list. This is a function here. This is the method, sorry. I call it push. And what push needs is just give it the data, the new data you want to use to insert the nodes. Now, how does it work? First, to insert the nodes at the front, you create a new node containing the data the node you want to insert in the double linked list will have. You call it the node new node. Now, you can see that here, if we want to insert at the front here, we need next to be pointing to the node, and then we have the new node will now be pointing to this front. The new node will be pointing to this front in its next. So that's what is happening here. The next of new node pointer will point to the front or the head, which is self the head. Then the previous of the new node pointer will be pointing to null, because every head node has a point, the previous has a point to null. Now, we'll go on to asking ourselves, if there is no head, maybe this is the first node, just say let the previous of the head point to the new node. Now let the head pointer itself now point to the new node. So let's see how we can apply this. So remember, in the main, the first time I created the nodes here, but now push will create the nodes. So I'll say let's push 1, let's push 2, let's push 3 here. Now, how will the double linked list will be arranged? You know, the first time in line 48 we push 1. Now, if we push 2 in line 49, what will happen? 2 becomes the head node and 1 is no longer the head node. If we push 3 in line 50, 3 becomes the head node and 2 is no longer the head node. So the linked list is arranged in 3, 2, 1. That means 3 is the head node, 2 is the middle node, and 1 is the end node or the tail. So let's see how this works. So I don't like this. Let's run it again. So you see, we have 3, 2, 1 as the nodes we have pushed. We are only pushing from the head. So first 1 was the head, 2 became the head, then 3 became the head. Now, that's for inserting nodes at the head or the front. What if we want the ability to insert nodes in any position apart from the head and the tail? This is the method I wrote for it. I will explain each of them. Just remember, you have a link to get all these codes and you can go through them later, but I just want to explain the codes in a way that you understand. So when you are reading it, you understand what it's all about. Now, to insert a node at any position apart from the head and the end or the tail, we have this insert after method. The insert after method, I'm using a node. If you check online, you'll see many of the references online will tell you to give you the previous node. But because my double linked list is database, is based on the data, I'm asking to give me the previous data. To search for the previous data, then you have to give it the new data you want to insert. So before you start, you check first if this previous data exists. You first check if this previous data exists in the double linked list by traversing the double linked list. So that's what you first do. So you say why the current is not known while you are still traversing through the double linked list. You check if it exists. Then if you have a match, you print out that previous node exists because the data exists. Then you break out of the loop. But if for the current it doesn't exist, you move on to the next. You keep on moving on to the next, finding the previous data until you get to the end. Now, if you have finished this loop or you broke out of this loop and you come here, so it says that if the above loop completes without finding a match and you are here, that means the previous data you are looking for does not exist. So you print out that the previous data doesn't exist in double linked list, because you need the previous data to be able to know the position after you insert the node. Then you end the method. The method returns. But if it doesn't end, if the method doesn't end, so we have gotten the current node from this loop. So we'll start. We'll say create a new node. Then let's for example, if this is the current, you break this chain. You break this chain apart. This current, the next points to this end. When you break this chain, this current, the next will point to the new node, and the next of the new node will point to this end, while the previous of this end will point to the new node, and the previous of new node will point to the current. So that's what this stuff is doing here. So let the next of new node point to current dot next, the next of current, and let the next of current point to new node here. Then let the previous of new node point to current. Then you check if the new node is not the end of the double linked list. If it's not the end of the double linked list, then the node coming after the new node, its previous pointer will point to the new node. So that's it. So let me just try out we'll try out some examples here. I'll show you how the process works one after the other. First, in this, this is how we check the code. First, we created the double linked list and we push one payload of 1 as the head. So this payload of 1 as the head. Then we inserted 2 after the head after 1. So this is the previous data 1 and this is the new data 2. We inserted 2 after 1. So let's see how the double linked list will look like. To be 1 pointing to 2. This is 1 pointing to 2. Then we'll say, okay, I want to insert 3 after 5, the node containing 5 as data. But we know there is no node containing 5 as data. So it will tell me that a node containing 5 as data does not exist. Look at it now, how it draws. So the first code runs 1, 2, but this code here is line 79. Insert data load of 3 after data load of 5. It says the previous node with data 5 doesn't exist in Doubly because we have only data load of 1 pointing to 2. So you say it doesn't exist. That's it. So the correct insertion will be inserting 3 after data load of 2. So we need to insert 3 after data load of 2, and this is it. Previous node exists because data exists. So this is it. We inserted 3 after data load of 2. So that's how you can insert after between the front node and the head node using this insert after method. Now the third method I said I'll show you is how to insert node at the end node. And we'll call it append, just similar to what you have in a list. In a list, if you are adding to the end of the list, you are appending. So this is the append for the double linked list. So it's a very simple process. For example, let me show you what the process is all about. For example, we have this end here. If you are inserting a new end node, all you do is that you make the new node the next to point to null, just as this one is, and you just break this chain and say let this one next point to the new node, and let the previous of the new node point to this one, and that's all. And that's all we are doing here. So we just need the payload, the new data. You create a new node and then say, because it's going to be the last node, let the next point to null. Then we check if the double linked list is empty. That's between this line 82 and line 85. If double linked list is empty, we just say the new node becomes a head. But if it's not empty, we traverse. We just get a last pointer that starts from the head and traverse the list until we go to the last node, because we need to get the last node. And you see, when you are traversing, it takes time because of the extra pointers. That's one of the disadvantages of double linked list. Now, when we are the last, what we do is that you say let this next of the last node point to the new node, and let the previous of the new node point to the last. Earlier here we have said let the next of the new node become null in preparation of making the new node the last node or the head node. So let's show how we check the code to make sure the code runs here. You see, in line, I first created the double linked list in this line 100. Then I made one the head node in line 101. Then I inserted 2 and 3 after 1 and 2. So what we have at this line 103 is 1, 2, 3. That's it. So let me show you that that's what we have. You are familiar with push and insert, right? So push and insert are not strange. So we have 1, 2, 3. Ignore this printout. Now what we have 1, 2, 3. What we want to append 4 at the end of the double linked list, we just call the append method on the double linked list. Now I'll print it out. Now I'll print it out for you to see it. So I've called append, and it has made appended 4 to the end of the double linked list. Now another cool feature I wrote that I'd like you to learn about is how to delete a node. How you can delete a node you can delete a node from any position in a double linked list. So it's just a simple data, nothing there. See, this is what you get in double. For example, you want to delete a node. First thing you have to check is the double linked list empty. That's what you check. And you also check if the node you want to delete, does it exist in the double linked list. That's also something you check. Now, if you want to delete the front node, you know what to do now. What you do is that you just break this chain. If you want to delete this front, you break this chain and let the head pointer point to this one, and let the next of this one point to null. That's all you do. If you want to delete the head node, all you do is you garbage collect. All you do is you just break this chain and let the next of this point to null, and you garbage collect this one. It's very, very simple. And if you don't understand the concept of a double linked list, I will encourage you to look back to the single linked list videos. We have 2 videos on single linked list, and you can find them on this channel in the playlist. Just go to the data structures playlist. You see single linked list part 1, part 2. Check them out, because you need the farm graphs of single linked list to really get the graphs of double linked list. So let's write the code for the deleting of nodes for double linked list. Now we'll go through the base cases. The first base case is the double linked list empty. If that means self.head will be null. So if you say self.head is non-return, that's all. Now, does the second base case is, does the node exist? The node containing this data payload, does it exist in the double linked list? So you check it between lines 105 to 114. So in this line 105 to 110, what we are looking is if the node exists. So we use a while loop. So here says if you have a match here, you break out of the loop, but if not, you keep on going to the next of the current. You keep on going until you get to the end. Now if you get to the end and you don't have a match at the end, that means in this line 112 current is none, and you break out of the method and you print out that node doesn't exist. But if you come to this part of line 116, if your code comes here, that means you pass the base cases. It's not an empty double linked list, and also the node does exist. So what you just do is, if you are deleting the head node, as I told you before, you just say the head points to current to the next of our current. You know, if you are deleting the head node, that means our current will be the head node. So the head pointer just points to the next. That's all. You garbage collect later. Garbage collect that node that was formerly the head. Now, if you also check if we are not deleting at the last node. If the node you are deleting is not the last node, all you have to do according to 1, 2, 3, and 1, 2, 4 is you just say, okay, let the previous of the previous part of the next point to the previous node, and you garbage collect. And also you check if it's not the first node. If it's not the first node, then you say the next of the previous node point to the next of the current node, because it's the current you are deleting, and that's all. After everything, you garbage collect. This gc.collect is garbage collection. I put in you have to import the garbage collector here. So I put in import gc as the first line. So after everything, you just ask garbage collector to collect the deleted node and take it away from memory. That's all. So let's show how it works. You are familiar with lines 135 to 140. So the new line is just 141. We are deleting node 2. But first of all, let me show you how the double linked list looks like. So the double linked list is 1, 2, 3, 4. 1 to 2, 2 to 3, 3 to 4. Now we'll say let's delete node 2. Let's delete node 2. So you see, node with data 2 exists for deletion. So we delete it and it becomes 134. So friends, that's all for the double linked list data structure in Python. I hope you download the Python files, which will be in the description, so you can go through the code and practice it in your own local machine. And I'll encourage you to also try out other things about double linked lists. You can find out other problems on double linked lists on websites like LeetCode or HackerRank. Go through them and try it out yourself. I'm sure you now have a firm grasp of what it takes to write codes that uses a doubly linked list. Watch out for my next Python video, and I'll encourage you to subscribe to this channel and also like the video, so it encourages me to post new videos like this that will help you transition from a Python novice to a Python pro. Thank you.